Okay, let's dive right into this explainer. Today, we're looking at something absolutely fascinating. It's this hidden, almost invisible structural flaw in the AI systems that you and I use literally every single day. We rely on AI for so much, right? Answering questions, drafting emails, breaking down massive topics, and we usually trust these systems completely. But there's actually a pretty huge crack in the foundation of how these models are built. So to really wrap our heads around it, we're going to explore what's called the architecture of authority and figure out exactly how we value veracity, basic truthfulness, in our data systems.
You see, there's this quiet, super counterintuitive assumption that is powering pretty much every modern AI data pipeline right now. When data gets scraped, collected, and dumped into these massive intelligence models, it goes through a process called flattening. Think about how web scraping tools actually operate in practice. They are pulling in millions of bytes of info every single second, and they definitely aren't pausing to check a source's credentials. They just reduce everything to raw text. So a completely random, totally unverified blog post gets thrown into the exact same hopper as a rigorously peer-reviewed scientific journal. Structurally, the system treats them as complete equals. Just let the tension of that flaw sink in for a second. Every data point enters as if it carries identical authority.
But here's the massive, glaring issue with that. Reality does not work that way. At all. In the real world, human information is incredibly nuanced. It has an origin story, it has a track record, a history. Think about it. If you ask a trusted friend for advice versus just overhearing some random stranger on the bus, you naturally weight that information differently in your mind. You don't flatten it. And yet the data architecture supporting our most advanced technology completely ignores this fundamental human reality. Section 1. The danger of flat data, ignoring origins. Let's look at what happens when systems ignore how information is actually formed. So to really understand this danger, we need to look at the two very distinct types of data signals entering these systems. On one side, we've got weak signals. These are uncertain, maybe incomplete, or just still evolving. On the flip side, we have proven signals. Now, these are the gold standard, info that has survived repeated validation and been backed up over time by independent sources. Picture a courtroom witness stand for a minute. A weak signal? That's like a witness repeating some rumor they heard third-hand at a local coffee shop. But a proven signal is a witness handing over a time-stamped, corroborated, legally verified document. In a courtroom setting, treating those two witnesses as equals would be absolutely crazy, right? It would completely undermine the whole pursuit of truth.
And honestly, that brilliantly illustrates the danger of the current landscape. Because of that structural flattening we talked about earlier, weak signals can stand beside proven ones with equal influence. That coffee shop rumor gets the exact same microphone and the exact same volume as the verified document. It's wild to think about, but we are essentially building architectures that allow a confident guess to be treated with the exact same weight as a scientifically validated truth.
Ultimately, the real cost here is that when everything is flattened out, these systems completely lose the ability to distinguish confidence from possibility. They literally cannot tell the difference between what might be true and what is definitively true. And this matters immensely to you and me, because if an AI can't tell a possibility from a proven fact, its output basically becomes a gamble. That's exactly how we end up with hallucinations, confidently delivered misinformation, and eventually a total breakdown of trust.
Section 2. Codatta architecture, embracing uncertainty. Now let's transition and look at a really elegant structural solution.
Thankfully, there's a massive paradigm shift happening right now. Let's explore how the team at Codatta.io is approaching data differently. They're championing this concept called an architecture of authority. Basically, it's a total reimagining of the data pipeline. Instead of looking at uncertainty as this messy problem that just needs to be flattened or hidden away, this architecture actually embraces it. Uncertainty becomes part of the structure itself. The goal isn't to pretend all data is perfectly factual, but to meticulously maintain the context of trust around every single data point.
In practice, this architecture relies on 4 really fascinating core pillars. First off, high-confidence contributions naturally gain stronger influence in the system, so when a signal gets validated repeatedly, its weight goes up. Second, and this is a real game changer, lower confidence signals actually remain visible. You don't have to delete that coffee shop rumor. You just accurately label it as a rumor, so the system knows exactly how to handle it. Third, the historical context stays permanently attached to the data forever. And fourth, uncertainty itself actually becomes a measurable metric within the AI. It proves you absolutely don't have to delete uncertain data, just as long as it's properly weighted and totally visible.
It really is a beautifully elegant solution. Nothing disappears. Everything just gains meaning through its context. By preserving the history, the validation, and the origin of the information, a weak signal isn't this dangerous contaminant in our data pool anymore. It just becomes a recognizable, lightly weighting possibility. The whole system becomes incredibly honest about what it knows for sure and, what it's still trying to figure out.
Section 3. Teaching AI to trust. The next evolution. Let's see how this builds into the future of artificial intelligence.
All of this brings us to a really profound shift in how we need to think about the future of AI going forward. This quote really hits the nail on the head. Intelligence becomes more reliable when systems do not only learn information, they learn how much trust that information deserves. That is the critical evolution we're witnessing right now. We're moving away from systems that just blindly memorize flattened data and moving towards systems that actively measure veracity. It's kind of like the difference between a student who just memorizes a textbook for a test and a true scholar who actually understands the context, the biases, and the reliability of the sources they're studying.
Which leaves us with this final, incredibly vital question to ponder the next time we interact with these models. Are we teaching AI facts, or are we teaching it trust? Because as we've seen today, a fact completely divorced from its context of trust isn't really a fact at all. It's just another random data point echoing in a flat room. Think about that the next time an algorithm confidently hands you an answer. Thanks so much for joining me for this explainer. Keep asking those hard questions, and I'll see you next time.